resistors in series and resistors in parallel. Let me consider three resistors here. Draw this diagram. We have got the potential here with positive and negative electrode, and this is the voltage V, where we have resistor 1 and resistor 2 and resistor 3. Across the resistor, the voltage is V1. Across the resistor 2, we have got the voltage V2. Across the resistor 3, R3, we have the voltage V3. But the constant current is going in this way. So this is I, this is also I everywhere. You know very well the electrons are moving from the cathode to anode, is it not? From negative electrode to positive electrode, but the direction of current is the opposite way. And that's why I put from plus to minus the direction of current. Here, the net voltage is V1 plus V2 plus V3. We know V is equal to IR. Therefore, V1 is equal to IR1. I is constant, is it not? So, V is equal to, instead of V1, I can put IR1 plus IR2 plus IR3. So I is constant, that can be taken outside the bracket. So R1 plus R2 plus R3. So I into R1 plus R2 plus R3. So this is V. So V is equal to I, we can put RS. It means RS is equal to R1 plus R2 plus R3. So resistance in series. Similarly, resistors in parallel. Positive electrode, negative electrode. Let us have a terminal here, another terminal, where from the connections are made in parallel circuit like this. And another parallel circuit, parallel resistor, and another parallel resistor. Let me call it resistor 1, resistor 2, resistor 3. Now, since they are parallel, I1 will be changing here. So here it is I1, here it is I2, here it is I3. Do you understand? Whereas across these junctions, V is constant. So this is I, and this is returning as I. Now we can write down like this: I is equal to I1 plus I2 plus I3, total current. And what is I in terms of Ohm's law? V by R, is it not? So I1 by I1 is equal to what? V divided by R1. So we can replace I2 by V by R2, I3 by V by R3. Therefore, I is equal to I1, instead of I1 I can put V by R1 and plus V by R2 plus V by R3, and this I can also be written as V by R is equal to V by R1 plus V by R2 plus V by R3. So V by R is equal to, V is constant, so 1 by R1 plus 1 by R2 plus 1 by R3. On both sides V can be cancelled. Therefore 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the parallel connection. So the reciprocal of net resistance is equal to the sum of 1 by R1 and 1 by R2 and 1 by R3. Got it?